Hello there. Welcome back. It is Visca the teacher, and we're going to change paths here for a moment. I've recently put up several videos going over an Algebra 2 Regents examination in its entirety, and now I would like to go over an AP Calculus AB exam. This is from 2017. All right, I will put up several videos doing so many questions per video. And I think it's time we get some calculus work up there. Okay. Um, if you're not familiar with the format of an AP Calculus exam, it's very similar to an SAT, in such that there is a section where you get a calculator, there is a section where you do not get a calculator. All right. We are going to start. This is the first video. We are going to do questions 1 through 10. This is section 1, part A. It's made up of 30 questions, so there'll be 3 videos, 10 questions each. And oh, by the way, for section 1A, you can see down here that no calculator is allowed for this part of the examination. So you will not see me call up my calculator for any of these problems. But don't worry, I think you got it. A lot of students get nervous when they don't get a calculator. But the AP Calculus exam makes the questions without a calculator so much more doable in terms of the algebra behind it. They would not give you a question that is near impossible for you to calculate without a calculator. And you'll see that as we move forward. So let's begin. Problem 1. If f of x is 2x squared plus 5, all raised to the power of 7, then f prime of x is. They are asking us for the derivative. And as you can see here, very simple, as long as you know your rules, okay, this question is not an issue. We need to do the simple power rule. I work outside my parentheses. I am going to bring that 7 down first, okay, 7. What's inside the parentheses will remain the same, and I subtract 1 from my exponent. And as I said, what's inside the parentheses is going to remain the same. So that's going to be 2x squared plus 5. Then we multiply, chain rule, by the derivative of the inside. 4x. That is the derivative of the inside. Notice I don't have any response that currently looks like this. Okay? So what I'm going to do is multiply my 7, which is outside the parentheses, with my 4x, which is also outside the parentheses. 28x times 2x squared plus 5, and that is raised to the power of 6. Choice D. All right. One more thing before we go on to question 2. I get a lot of students that ask me, are we going to have to simplify? Are we going to have to simplify? Any short answer questions, they rarely tell you to simplify, okay? But when it comes to multiple choice, they don't tell you to simplify. If they want the answer simplified, that's how they'll present the answer, okay? So if this was short answer, what I have written here would have been completely acceptable. But when it's multiple choice, you better figure out how to make this answer look like one of these. In this case, choice D. Number 2, integrate 1 over 3x plus 12. Okay, if I integrate that, what will I end up with? Well, I'm going to use a little bit of u substitution. All right? This would be much easier to integrate if it was just 1 over u, because I know the derivative of that, okay, or the integration of that would just be the ln of u. All right, so let me see. If I wanted to make the denominator u, I would have to state u is equal to 3x plus 12. So instead of this, I'm just going to call this u. All right? Which means if I have a u variable here, I can't have dx, I need a du. So if I have u up here, let's take the derivative of u to get du. That's just going to be 3. Oh, by the way, I need to carry the dx along for the ride. Okay? That means on the right side, I've just taken the derivative of a variable with x. Here's the problem or the issue. I don't have a 3 du here, or excuse me, a 3 dx. I just have a dx. So let's get rid of the 3 on the right side. I'm going to multiply both sides by 1/3. 1/3 and 3 cancel. So now I've got dx equals this, 1/3 du. So what I'm going to do is I'm going to take my constant and put it outside and put my du right here. Now I can integrate this. The 1/3 comes along for the ride. The integration of 1 over u is ln of u plus c. Always have to do that plus c if I don't have bounds on my integration. And I'm pretty much done. All I've got to do is get my u out and put my x variables back in. So for u, I'm going to put 3x plus 12 back in. All right? Here you go. 1/3 the ln of 3x plus 12 plus c. Now, when I first did this problem, just like this, notice the answer is not there. And it drove me absolutely crazy. So why did it drive me crazy? If this was short answer, I would accept this all day long. But you'll notice all of these responses have an x plus 4 in the ln. So what did they do? Okay. They took this right here and they factored out the 3. All right. And that becomes x plus 4. Okay? And what they do is they bump the 3 out, like right from the beginning. Meaning, okay, they have the integration. They call that 1/3 times 1 over x plus 4. They factor the 3 out of the bottom, right? And the 3 will still stay in the bottom, so it's like having 1/3 by itself. They pull the 1/3 out here and call it 1/3 integration of x plus 4 dx. Now they say u is x plus 4 du. Well, that's just 1 dx. So now I've got the, oops, sorry, that's 1 over. Now I have the integration of 1 over u du, because what goes in for dx is du, and the 1/3 is just on the outside floofing around here. ln of u plus c, and my 1/3 stays out here. U is x plus 4. So they actually factored out the 1/3 before they did any of the u substitution. I'll be honest with you, I did this problem once, and I was curious as to why my answer wasn't listed. I did it a second time, and then I just took note that in order to get this, you have to factor the 3 out of here first. And then that'll just pop out here. Then you do your u substitution. Okay, then this is going to be u substitution. Okay. And here you go. Tricky. Tricky. Not every problem is like this. This happens to be one of those anomalies, okay? Number 3. Okay, let's get going. This is another, they're just asking for the derivative. It is, the derivative of a fraction is low. D high, the derivative above, that would be -1, minus high, just as it is, d low, the derivative of the bottom, or the low, is 3x squared. I draw a line, and what whatever is below, I square. So I square below. It's a little rhyme, okay? It goes low, d high, minus high, d low. I draw a line, which is my fraction part, and then I square below. All right, well, I think all we're going to have to do here is just do some, and I said I squared below. That should be squared. The bottom is x plus 3, or x cubed plus 2 squared. That's the bottom for every single one. So all we've got to do is do the algebra in the numerator, kind of combine like terms. All right, so for this part here, I'm going to distribute my negative 1. So I've got negative x cubed minus 2. All right? For the back side, I'll go orange. For this part, not only am I going to have to distribute the negative sign, but then I'm going to have to multiply it by 3x squared. Okay? So it's negative 5 times 3x squared, which is negative 15x squared. We negate my negative x, it becomes positive x times 3. So it's positive 3x cubed. This is just the numerator. Okay? And when I combine like terms, I have 3x cubed minus 1x cubed. It's 2x cubed minus 15x squared minus 2 all over x cubed plus 2 squared. And I see that right here for choice C. All right, number 4. The table above gives the velocity in miles per hour of a truck at selected time t in hours, using a trapezoidal sum with 3 sub-intervals. That is telling you exactly what you need to do. It's the trapezoidal rule, all right? What is the approximate distance in miles the truck travels? So if I have velocity and I want distance, I'm going to do area under the curve. In this case, I'm going to use the trapezoidal rule to find just that. Now, I need to break this up into 3 subintervals indicated by the table. All right? So my first subinterval is going to go from 0 to 1/2, or 0.5. My second one is going to go from 0.5 to 2. And my third one is going to go from 2 to 3. All right? Now keep in mind, you don't get the use of a calculator. The trapezoidal rule says I take my width, which is whatever this distance is here, and put it over 2. And I multiply by, okay, the sum of all my values within that interval. Okay? And what I tell my students is if I'm adding like 4 things, 1, 2, 3, 4, the bookends do not get multiplied by 2, right? If I'm adding all these up, everything on the inside gets multiplied by 2 and doubled. In this case, I only have 2 values. I only have the bookends here. So nothing is going to get doubled. Okay? So I would take my 0.5, which is my width. Right here from here to here is 0.5. And I take my 20 and add that to my 60. Now, how come I can't use all of these y values and just double the 60 and 40? Because the widths of each subinterval is different. So I've got to handle all of those different widths as little separate trapezoidal rules on their own. So this is what will give me the area under the curve for my first subinterval. My next subinterval is from here to here. Okay, that has a width of 1.5. Okay, so I'm going to take whatever I get in red and add that. New trapezoid rule. I take the width and put it over 2, and I multiply it by all my values. I have 60 and 40. I have no middle terms in between 60 and 40 to double. So I just have 60 plus 40 plus my last subinterval has a width of 1 from here to here. Okay, so it's 1 over 2. And again, I just have bookends, 40 and 30. 40 plus 30. Now, these are nice round numbers. Okay? Again, this is a section where you don't get a calculator, so they expect you to be able to do this. All right? So 20 and 60 is 80. Okay? I cut that in half. Okay, I get 40. And then I multiply it by a half. I end up with 20. Okay, plus 60 and 40 is 100. I cut it in half. Okay, that gives me 50. 50 times 1.5 is 75. Plus, okay, 40 and 30 is 70. Half of that is 35. All right, well, I have 20 and 35 is 55 plus 75, well, 130. Choice B. That's not too bad. Number 5. If f of x equals sine of x squared plus pi, then f prime of the square root of 2 pi is. All right, well, we need to find the derivative first. This is telling me right here, find the derivative. And oh, by the way, when you get it, plug in the square root of 2 pi for x. So I got to take the derivative of this. Chain rule. I always start outside in. I take the derivative of the sine, and what's inside the parentheses will stay the same. Your rules for trigonometry. The derivative of sine is cosine. What's in parentheses stays the same. Now I multiply times the derivative of the inside. Forget about cosine, just the derivative of this. The derivative of x squared is 2x, and pi is a constant, so the derivative of pi would be 0. That is f prime of x. Now I need to figure out what's that exact value when x is a square root of 2 pi. So I've got the cosine of x squared. In for my x is the square root of 2 pi. Okay, that x is squared plus pi times 2 times my x again. Square root of 2 pi. All right. Let's get going. Well, let's start here. My square and square root are going to cancel, so I end up with 2 pi plus pi. All right, and 2 pi plus 1 pi is 3 pi. So I have the cosine of 3 pi, all right, times 2 square root of 2 pi. I need to find the cosine of 3 pi without my calculator. You better remember what the graph of cosine looks like. All right, here's 1 pi, here's 2 pi, and here's 3 pi. Okay, I'm just going to put a couple tick marks in between. We go up to 1, down to -1, and here's 0. Cosine is the cup. It starts up high, okay, and it ends up high. In the middle is down low. Okay, when I say in the middle, I mean at 180 degrees or pi. And in between those are when I hit the x-axis, all right? So I kind of got this thing. Bam. But I don't have 3 pi, do I? Because cosine will repeat the same thing over and over again, which means it'll go down to here. It'll just keep on going forever and again, forever and forever. So at 3 pi right here, the value is, oh yeah, I'll be okay. I will be okay. Watch the magic. Boop. I forgot. Shame on me. My tick mark's in between. Okay, then here would be 4 pi. So now we'll continue by here, down to here, back up, down, and so forth. So now, follow me, 3 pi is way down here, which is -1, okay? So this right here is equal to -1. So let's rewrite that. -1 times 2 square root of 2 pi. And all we're going to do is negate that. So it's -2 square root of 2 pi. Ooh. Choice A. Not too bad. 6 is really just a change in y over change in x. It's a slope between 2 points. How do I know that? Because it's asking me for the average rate of change. Here's my equation. Okay. If f is the function given by f of x equals 3x squared minus x cubed, then the average rate of change on the closed interval from 1 to 5 is. These are two x values, okay? Right now, I have an x value of 1, and I have an x value of 5, okay? So, we need to find the y value for each one of those. And we're going to do that by plugging our x values into our equation. If I plug a 1 into here, I get 3 minus 1, which would be 2. If I throw a 5 into here, I get 5 squared is 25, times 3, that's 75, minus 5 cubed, which is 125. So I get -50. All right? All right, let's do this. Change in y over change in x. I got -50 minus 2 all over 5 minus 1. Okay, it's -52. Don't call this 48. That is -52 over 4. 4 goes in there -13 times. That's your answer. Choice B. Pretty easy. Number 7. If the integration from -10 to 4 of g of x d of x is -3, and the integration of 6 to 4 of g of x dx is 5, then the integration from 6 to -10, I'm sorry, I'm reading these from the top integral to the bottom integral. Okay, so the integration of 6 to -10 is g of x dx. All right, this is just testing you on your basic rules, your knowledge of those rules. All right, if I want this, I want the integration from 6 to 4, and I'm going to combine that with the integration from 4 to -10. In other words, when I combine these, 6 to 10, I want the number that I'm getting rid of kind of together, buckled together like that. Right now, my 4 is in the bottom, and my -10 is in the top. Okay, I want that flipped. So there's a rule saying that if I flip this, then I have to negate the answer. So instead of being a -3, it would turn into a +3. Okay? So flipping bounds negates my -3 to +3. Now the integration from 6 to 4, well, that's 5. So all I got to do is add these. Now the integration from -10 to 6, right? Because this upper bound is going to touch this lower bound here. Okay, we basically have now this was 5, and now this was 3. 8. That's a simple one. If you know those rules, that is very, very, very simple. Number 8. If f is the function given by f of x equals e raised to the x over 3, or x times 1/3. That could be written as 1/3 x. Which of the following is an equation of a line tangent to the graph of f at the point 3 ln of 4, comma, 4? All right, I tell my students, anytime they ask you for the equation of a line in calculus, we are going to use y minus y1 equals m times x minus x1. Okay, here is your x1, and here is your y1. I'm not creating fractions. I'm just, I guess, telling you that's y1 and x1. So those are the first things we're going to plug in. Anytime we do a problem like this, finding the slope, which is the derivative, is the most work. Okay, so I have y minus my y1, which is 4, equals, I don't know my slope yet, or derivative, times x minus my x value, 3 ln of 4. Can you have that, mister? Yeah, that's what they gave you. So that's what you use. Stop trying to overcomplicate it. Here's where it's going to get fun. In order to find my m value, that equals the derivative of my function at the point of the x value in the coordinate. Okay, so not only do I want the derivative, which is my slope, but I want my derivative at this point right here, which means I need to use this x value in my derivative to find the actual numeric value of the derivative, or slope. Okay, so the derivative of my function first. Okay, anytime, I'm just going to say e to the 1/3 x. Okay, anytime I take the derivative of e, you start by writing it down exactly the same. E to the 1/3 x times the derivative of just the exponent. The derivative of 1/3 x is 1/3, so I'm just going to put that out front. This is the derivative here. So now I want the derivative at this x value, okay? At an x value of 3 ln of 4. So let's plug this into my x, okay? And let's do some algebra. It's going to get fun here. 1/3 e 1/3 of x, which is 3 ln of 4. Okay, right now, right from the bat, 3 and 1/3 are going to cancel. So now I've got 1/3 e to the ln of 4. Okay? I know they say this isn't mathematically correct, but it works because we're not doing all the math work to get there. My e and ln become a 1 and my 4 comes down. Okay? Meaning I have 1/3 times 4, which is 4/3. That's my m value. Okay? And if I go back up here, 4/3. The only equation that has 4/3 as an m is choice A, because you really didn't have to do anything with your y and your x. You were just plugging them in anyways. So, and there you go. Wasn't too bad. Really wasn't too bad. Number 9. This one I like, and you know what? I like to get to use highlighters on this smartboard software. I love using highlighters, and they're going to come in handy here for number 9. So, lucky me. Number 9, the graph of the function f is shown above. Which of the following expresses the relationship between the integration from 2 to 0 of f of x, the integration from 3 to 0 of f of x, and the integration from 3 to 2 of f of x? All right, so integration is the same thing as area under the curve. So I'm just going to be looking at areas under the curve here for the given intervals or bounds, okay, provided. Now, look at all my responses, okay? They are separated all by inequalities. So if you want, you can look and say the left one is smaller than the middle, which is smaller than the right one, or you can say this is bigger than the middle, and the middle is bigger than this one. So either way, I'm going smallest to largest, largest to smallest, whatnot. I'm just going to read this left to right, okay? And my smallest area should be listed first. The next smallest area should be in the middle, or I guess the middle area size, and then the largest area size should be listed last. So let's take a look at all of these areas. The first one, oh, here is my time to shine. The integration from 2 to 0. 2 to 0, that's this whole area under the curve. Hopefully it doesn't do anything funky like turn into a straight line. Bam. This is the integration, okay, from 0 to 2. So I'm just going to do this, do this, do this. This is from 2 to 0. Okay, that's a large area. All right, now let's do the next area. It's going to ask me from 0 to 3. You need to be careful. From 0 to 3. Oh, well, first of all, let's not make it look like 3 different colors. From 0 to 3, anything above the x-axis is considered positive value. Okay? Anything below the x-axis, like this stuff right here, this is considered negative. So when I combine these two, what I'm really going to do is I'm going to take my blue highlighter and I'm going to subtract the purple highlighted area. So why don't we do this so it like kind of fits here? Boop. Something like that. So really, I'm going to erase all this area here. Okay? That's the area from 0 to 3. Okay, here's oh my god. Oh my god. Oh my god. The erasing just took it all apart. All right, so there you go. That is from boop, 0 to 3. Obviously, this is the biggest one so far. This is the biggest one. All right? The last one says from 2 to 3. You know, I just highlighted this. This is going to be the smallest one, okay? This is also a negative value, but it's the smallest area under the curve. So I'm going to take this, grab this out here, and whoop. This is from 2 to 3. This is the smallest, and this would be the mid one. So if I'm going from smallest to biggest, I want 3 to 2 listed first. So it's either going to be choice C or it can't be this one or this one. I want 3 and 2 listed first. Then I want my middle one to be 3 and 0. Here we go, 3 and 0. And the last one has to be 0 to 2 because that is my biggest one, 0 to 2. Choice D. Good, 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 good. Good. Call me a math nerd, but I really love doing these things. Here, let me move this up so I got a little bit more space. I just love doing these types of problems, okay? This is the way Algebra 2 Regents used to be. Here's a problem, solve it. Now it's all paragraphs and deciphering, and it's crazy. That's why I really like these calcs exams, especially the multiple choice part without the calculator, because they're doable algebra. And as long as you know your rules for derivatives and integrals, you are set. You are set for at least the part 1, okay? Now, let's go. I'm going to integrate this. I can't really apply the x cubed plus 1. I can't, like, to the power of 1/2. That's under a square root. That's going to be messy. So this is what I always tell my students, okay? If you come across an integration, an integral, and the derivative of one function is listed there, if there's a function and its derivative listed there in some way, shape, or form, u sub. So what does that mean? I'm going to say that u is a substitution, or it's going to be the same as. So my u is going to be x cubed plus 1, okay? That means my du, okay, the derivative of x cubed is 3x squared. So my original function, my derivative. No, I don't see the 3, but I see the x squared, which is the important part. All right? So my derivative of x cubed plus 1 is 3x squared dx. Now, a couple of things here. All right? I only have x squared dx that I want to substitute in for. I only have x squared dx. I want to get rid of this 3 in front, so I'm going to multiply both sides by 1/3. All right? The 3 and the 1/3 cancel. And now 1/3 du is going to go in for my x squared dx. So right off the bat, I have du, okay, and my 1/3. I will put that on the outside of my integral. Any constant, I always put on the outside. All right? So my 1/3 du, that's in. Good, check. U is going to be substituted in for x cubed plus 1. So I'm just going to say that's u to the 1/2. However, if you have bounds, 0 and 2, you need to make your bounds in u form. You see how you now have u, you have du. Your bounds also need to be in u form. Right now, you have x cubed, you have x squared dx. These are currently x form, okay? So how do I make those x forms into u? Oh, well, it's simple. Okay, right now, x equals 2 and x equals 0 are my bounds. So also, I just use this. What if x is 2? 2 cubed is 8, plus 1. That would give me a new upper bound of 9 in terms of u. What about when x is 0, the lower bound? Okay, what about when x is 0? Well, 0 cubed is 0, plus 1. When x is 0, the u value would be 1. So my lower bound in terms of u is 1. This is a million times easier to integrate. All right, so I add 1 to my exponent. All right, I add 1 to that exponent, and then I divide by that value. And something we need to keep in mind is as follows, okay? That's going to be u. If I add 1, it's going to be 3/2. Okay? I train my students to say, whenever I divide by a fraction, I multiply by the reciprocal. So I can say divided by 3/2. But that's just going to mean I multiply by the reciprocal. So I'm going to write it like that, okay? Which is going to make my life slightly easier. So the integration of u to the 1/2 is 2/3 u to the 3/2. And, oh, by the way, I still have my 1/3 on the outside. I don't need a plus c because I have bounds. I want this from 9 to 0. All right, so let's do some math. Let's go up here. 1/3. I'm going to plug in the 9 first. Okay, 2/3 times 9 to the 3/2. Okay, minus, because it's the difference. We haven't done that yet. We haven't actually done one of these out completely. And I mean like with bounds. Okay, now I'm going to plug in the 0. Oh, 0, it's 1. Why did I put 0? Look at that. Good thing I caught that. That would have been terrible. 2/3, 1 to the 3/2. Okay, I'm multiplying here. There we go. So I still have my 1/3 on the outside. The square root of 9 is 3. 3 cubed is 27. So I've got 2/3 times 27. Okay, minus. All right, 1 to the 3/2 is 1. 1 times 2/3 is just 2/3. I still have my 1/3 on the outside. 27, well, actually, let's do this. 3 goes into 27. Nah, I'm going to have to combine it with that 1/3. I'm going to keep this a fraction. 2 times 27 is 54. 54 thirds, okay, minus 2/3 will give me 52 thirds. Okay, so let me scroll on down here, give myself just a little bit more room. 52 thirds. Oh, by the way, times 1/3. It's 52 ninths. That's what my answer should be. And that, my friends, is choice A. Look at that, perfect. Choice A. All right, we're done. I'll have another video with problems 11 through 20. That wasn't too bad. I mean, it's 40 minutes. I normally like to keep my videos around 30 minutes, but I do some explaining along the way. Just don't do the work, then go on to the next problem. If you want something like that, go ahead. There's probably tons of videos out there, or you can fast forward through mine. But I assume you're here because you need some help. And if you need some help, you need some explanation. I don't do it for every problem, but I do it for enough problems. By the way, you like the video? Give it a like. Ring that bell. Ring a ding ding. It's not going to offend me any. Follow me, will you? And then you'll be notified of the other videos I put up for this or more math work. All right? Have a good one. Bye-bye.